Friends, we are moving on to trigonometry 15, and we'll be looking at other examples. So we want to look at the double angle identities. Over here, we'll be using the compound angle formula, and then we'll be replacing B with A. And so where we have A plus B, to be A plus A. So sine 2A will be giving us 2 sine A cos A. Cos 2A will give us cos squared A minus sine squared A. And tan 2A will give us 2 tan A all over 1 minus tan squared A. Look at it carefully. Right. Now, we can also be looking at cos squared A minus sine squared A and expressing it in terms of sine. So cos squared A will be replaced with 1 minus sine squared A. When we simplify, minus 1 sine squared A minus 1 sine squared A becomes 1 minus 2 sine squared A. They want to express this in terms of cos. So, in place of the sine squared A, we put 1 minus cos squared A there. And so, this minus will affect the 1 and then this, and that will be positive. So, we shall get 2 cos squared A minus 1. And so, we can express our cos 2A in this way, cos squared A minus sine squared A, or 1 minus 2 sine squared A, or 2 cos squared A minus 1. So, in these three forms, we have it this way. Look at all this carefully and register them on your mind. We also have 2 sine squared A being equivalent to 1 minus cos 2A, and then 2 cos squared A being equivalent to 1 plus cos 2A. We'll be using all this, so take notes. Right, prove the following identities, and let's look at the first one. We are showing that this will give us that. So 1 minus cos 2A can be expressed as 2 sine squared A from the identities we have just discovered. Sine 2A can be written as 2 sine A cos A. So this 2 will divide that, and then sine A will divide sine squared A, so we get sine A. Then we have our cos A. So sine A over cos A is tan A. So we've been able to show that this is equivalent to that. Right. Now I also want to show that tan theta plus cot theta is equivalent to 2 cosec theta. We know that tan theta is sine theta over cos theta, and then cot theta is 1 over tan theta. So we find the reciprocal of this, and that gives us cos theta over sine theta. Now we find the LCM, that is sine theta cos theta. So cos divide cos, and then get sine. Sine times sine gives us sine squared theta. Sine divides, we get our cos theta times cos theta gives us cos squared theta. The numerator will give us 1, so we have 1 here. Now sine theta cos theta. Let's introduce 2 on top and introduce 2 here. So we get 2, and then this one, 2 sine theta cos theta gives us sine 2 theta. And then this one, we know that 1 over sine 2 theta is cosec 2 theta. So we get 2 cosec 2 theta. So look at how we did it. We employ the identities we have studied before. That helps us to arrive at the correct answer. Right. Let's move on to the third question. We have the whole of this expression. I want to show that it will give us tan A. So over here, cos 2A, we express it as 1 minus 2 sine squared A. And then sine 2A, we express it as 2 sine A cos A. Then our cos 2A, we express it as 2 cos squared A minus 1. Then sine 2A, we express it as 2 sine A cos A. Now, 1 minus 1 will be 0, so we'll be left with this and that, so that comes here. Then this 1 minus that will be 0, and then this and that will be positive. So we get this and that as the numerator. The next step is that we have sine squared here, so there is sine there. We have sine A, so we can factorize the sine out. We have cos squared, so there is cos there. We have cos here, so we can bring out the cos. So over here, we are going to we have 2 there, 2 there, 2 here, and 2 there as well. So we can factorize our 2 sine A out, and then we get sine A plus cos A from the numerator. Then at the denominator 2, we can factorize 2 cos A out, and then we get cos A plus sine A. Look at it carefully. Now cos A plus sine A plus cos A, addition we know is commutative. So what we do is that we can divide this. Then these 2 divide us, so we shall get sine A over cos A, and that gives us tan A. So we've been able to show that this is equivalent to that. Look at the steps and how we did it. You can try your hands on that once again by covering the answer and trying to see how you can solve the game. Thank you so very much for your attention. Have a blessed day.